This video looks at electron structure. Eventually, at the end of this series, we'll be at the point where we're able to predict the properties of a substance that we don't know. Before that, in order to predict the properties of something, we've got to know the structure of it. And before we can know the structure of it, we've got to understand the bonding within that substance. And to understand the bonding, we need to understand about electron structure. So this is the first building block, if you like. We use the periodic table, and that tells us a few different things. So first of all, we've got the periods going across. The period number tells us the number of electron shells. So electrons are in shells. Each shell tells you that the electron is a bit further out from the nucleus. It also describes the energy level of the nucleus of the electron. And this first one here, period 1, has only got these top two in. Then we've got groups which go down. They're the columns. And the group number tells you the number of electrons in the outer shell. Now, sometimes you see these numbers that go up and then it goes into the teens here, but the ones that you need to be worried about are the numbers that go 1, 2, miss out this block, and then go to 3, 4, 5, 6, 7, and then 8, or sometimes this is called group 0 there. So if something is in group 2, that means it's got 2 electrons in its outer shell. The only other bit of information we need for this is the atomic number for each element tells you how many electrons, because it's the same as the number of protons. Okay, so I'm going to go through and show you how to draw electron structures. So I'm just going to use just a little dot like that just for the nucleus. Hydrogen, it's got 1 electron. It's in period 1, so it's going to have just 1 electron shell. And I'm going to show that electron as a cross. Sometimes you could show it as a dot, that's fine. I'm just going to use crosses this time. Going across to helium, it's got 2. It's still in the first period, so I'm going to put that one there. Going to lithium, we're into the next period, so I'm going to draw the next shell out. And I'm going to put the 3rd electron in there. So it's got 1 electron in its outer shell. It's in group 1, you can see. Okay, beryllium. As I put these in, I'm going to put them around it in 4. So that was boron, then carbon. Going to nitrogen, I'm going to start pairing them up the way I draw them. So that's oxygen, fluorine, and neon. So neon has got 10 electrons in total, 2 in the first shell, 8 in the next shell. And now I go on to sodium, and it's the 3rd period now. So I'm going to draw my 3rd electron shell. And 1 electron in its outer shell because it's in group 1. Those are my 11 electrons for sodium. Magnesium, aluminium, silicon. I'm going to keep going around, adding them in until I've got to argon there. Okay, and now I'm going to go on to potassium, 19 electrons. I'm going to my next period, period 4. So I'm going to draw my 4th electron shell on. 1 in its outer shell, that's potassium, and then calcium, 2 in its outer shell. Now I get to this block in the middle, the transition metals, and that's where I'm going to stop, because this model here doesn't account for these transition metals. It can't tell us anything about the elements after calcium. Doesn't mean that this model is wrong. It's just a very simplified model. Everything you do in science is simplified models, including A-level and university. This is just more simplified, so it can't tell us anything about these elements. It's very useful, though, for the elements that we've just done to be able to know about the electrons in them. So, as an example, I'm just going to pick out a random element. Let's do aluminium, and we'll draw that one. 3 bits of information, remember. The atomic number tells us there's 13 electrons that we're going to need to draw. The period number tells us how many electron shells there are. It's in period 3, so I'm going to need to draw 3 electron shells. And the group number tells us how many electrons are going to be on that outer shell, and that is 3. Okay, let's start putting our 13 electrons in the order. First electron shell holds a maximum of 2. Then the next 8 go in this next shell. And then that leaves us 3 going in this outer shell. So that's how you do it. That's how you use the information from the periodic table to draw the electron structure. And for those first 3 shells, the maximum they can hold is 2 in the first shell, then 8 in the next shell, and then 8 in the third shell. But the amount you put in is dictated by that atomic number. Last thing is something called the octet rule. The reason why this is important is because to be stable, atoms want to have a full outer shell. So they will react to have a full outer shell, which means they will lose or gain electrons in order to get a full outer shell. So for example, if we looked at sodium, it's in group 1, it's got 1 electron in its outer shell. To get its full outer shell, it's going to lose 1 electron. Aluminium here has got 3 electrons in its outer shell. To get the full outer shell, it's going to lose those 3 electrons. Or fluorine, which has got 7 in its outer shell and wants just 1 more, would gain 1 electron to get its full outer shell. So that's why electron structure is important.